Hello and welcome to the Daily Space for today, November 30th. My name is Dr. Pamela Gay, and I am here to put science in your brain. For the next few minutes, I'm going to do a fast-paced run-through some of today's top stories in astronomy and space science. As always, this is brought to you by CosmoQuest.org, your place to go and learn and do science. We're a production of the Planetary Science Institute working in collaboration with Youngstown State University. Now, in today's top story, or at least first story, I'm not sure it's the top, yesterday NASA announced its new partners for commercial moon exploration. The companies that it picked were in some cases new and in some cases, well, companies some of you may not have heard of before. The list is Astrobotic Deep Space Systems, Draper, that's the same Draper that does robots you may have heard about, Firefly Aerospace, Initiative Machines, Lockheed Martin, Maston Space Systems, Moon Express, and Orbit Beyond. Now, two things struck me in this particular list. One is that there are at least two prominent Google Lunar X Prize competing teams on this list. Both Astrobotic and Moon Express really made a name for themselves in competing to get to the moon first. And while neither of them has yet got there, they built up the infrastructure needed to convince NASA that they've got what it takes. Now, as always, it's you kind of expect to see either Lockheed or Boeing on one of these lists, and in this case, we've got Lockheed. The one that surprised me not to see here is SpaceX. Now, it could be this is just not quite what they were aiming to do. They are, after all, putting their eyes on Mars. But nonetheless, this is the kind of interesting news that gives us a sense of just how we're going to get to Mars in the future. Now, moving out a bit further in the galaxy, we have a story of, well, a galaxy. In this case, we have a story involving a supernova in the galaxy. More than 150 scientists were involved in studying supernova 2018 OH. This particular system was serendipitously located within the observing field of the Kepler K2 mission. This was the extended mission that allowed Kepler to keep doing science even after it wasn't able to do all of the original, well, fine pointing that it was planned to do. During its very final days, it just happened to catch within its field a supernova rising in brightness and then slowly falling. Now, while the slowly falling was exactly what you'd expect in a supernova, the rise was not. This particular observation, where they had Kepler images coming in every 30 minutes documenting what happened, showed that this system rose in brightness much faster than expected. Exactly how you get this kind of an early bump in the light curve of a supernova, that plot of light over time, is one of those things that, well, led to many raised eyebrows. There were multiple theories put forth, and the two that seem to be, well, leading the way are that perhaps the supernova outflows went across the companion star. This was a type 1a supernova, the type of supernova that occurs when a white dwarf star pulls matter off of its companion until it gets so big that it's no longer able to support itself against gravity. At this point, it collapses down and it explodes outwards as a supernova. This is the kind of explosion where they should always occur at the exact same mass and in pretty much the exact same way. But occasionally we see these weird variations that have led some to think maybe there are two different classes of type 1a supernova, those that have this early rise and those that don't. Another theory is, well, maybe this is an alignment issue. And in cases like 2018 OH, what we're actually seeing is that material coming off the supernova, hitting the companion star, and we're at just the right angle that the light coming off of the companion star is visible to us where it might not be visible for people in other directions. And other supernovae won't have these kinds of alignments for us to be able to observe. It is one of these amazingly complicated systems, and there is still even one more interesting way that they've found to explain this, and that's that maybe there's an unusual distribution of radioactive material in the exploded star that, well, this goes back to the not all type 1a supernova are the same. Now, the idea that not all type 1a supernova are the same is one that is extraordinarily concerning, because objects like this, we assume, since they should all explode at the same mass and explode in the same way, that they should all give off the exact same amount of light. And if we know how much light comes off of something, and we know how bright or faint it appears, we can calculate its distance. Well, if it turns out not all type 1a supernova are actually the same, we can't calculate that distance. So here is to hoping that this is actually something that has to do with the alignment, that it's the companion star or something like that, and that we can figure this out quickly to remove some of the question marks on our cosmological understanding of the universe. This is an amazing set of observations. We were so lucky that Kepler held out as long as it did, allowing this one last fabulous piece of science to be completed. Now, continuing our journey through the universe. In research that was led by Marco Agello, a scientist at Clemson University, astronomers have used the Fermi Gamma Ray Observatory to try and calculate just how much light has been given off by all the stars in our universe. And this is a really cool piece of research, because the way they're doing it is they looked at 739 active galaxies, a specific kind referred to as blazars. These systems have gamma ray jets that we can observe, and it turns out that thanks to Einstein's E = mc squared, when that gamma ray light collides with infrared light, this can lead to the creation of matter. That energy from those two different photons can get flipped into mass, becoming a positron and an electron. And by observing all of these different gamma ray rich systems and observing the interactions the light had on its way back to Earth, they were able to measure all that starlight that was given off in colors that interacted with the gamma rays. By going through and doing very careful calculations of all the things they saw, they were able to figure out that more or less the number of photons that have escaped into space that were emitted by stars, so here they are only measuring starlight, the amount of light coming from stars across all our visible universe is 4 × 10⁻84 photons. Now, for those of you not familiar with scientific notation, that is a 4 followed by 84 zeros worth of light. We don't even have language to express that kind of number. So that's kind of cool. They have figured out how to figure out some of these things. So those were the main stories for today, and on Monday we have some amazing news to bring you. The OSIRIS-REx spacecraft, which CosmoQuest is part of the team for, our little spacecraft is getting to its rock. It arrives at Bennu on Monday, somehow precisely at noon Eastern. I'm always amazed at the way they time these kinds of encounters. And we're going to start getting information back. And in the coming days, it's going to be a wild ride to figuring out where exactly the spacecraft is going to go in, grab up a rock that it's going to bring all the way back to Earth. Now, Bennu is not the biggest asteroid out there. It is a kind of run-of-the-mill near-Earth asteroid, not too far from our planet. It's not out in the main belt of asteroids. It's nearby. And it's only about 500 meters across. This means that it's not too much bigger in height than the Empire State Building. And Banu's out to explore it and find out just what this, well, rock has to scientifically offer us. We will be bringing you live coverage of that event starting at 11:45 Eastern Time. And we'll be staying with the program up until the coverage is over. So please show up 11:45 Eastern on Monday for this cool moment when our little spacecraft gets all the way to the rock of its scientific dreams. So at this point, I'm going to go ahead and I'm going to take your questions. I'd asked all of you to please @ me in the chat to make it easier for me to find your questions. As always, I'm Dr. Pamela Gay, and this is The Daily Space. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We invite you to go to CosmoQuest.org and help us explore our universe. We have citizen science projects that give you chances to map out rocks, to find craters on other worlds, and to do the kind of work that we can't yet program computers to do. It's your efforts that will help us program those computers and will help us find the scientifically interesting places to explore and the safe place to land the spacecraft that's going to do that exploring. So thank you, and as always, we are also supported by you. We exist thanks to your bits, your subs, and your donations. This year, more than ever, we are asking for your help to fund everything we do. We'd been warned earlier this year that there was a chance that due to James Webb Space Telescope cost overruns, due to changes in citizen science policies, we might see cost cuts, and we saw some massive cost cuts. And without your help, I'm going to have to lay off most of our staff for Christmas, and I really don't want to do that. We're in the process of doing a massive Christmas time fundraiser, and the weekend of December 22nd, we're going to bring you 40 straight hours of content. It's our hope that we can earn your donations, and you will make it possible for me to pay my staff long enough to find new federal funds. So if you can help, please. I've fired people before. I don't want to do it now. So thank you. And now I'm just going to take your questions because questions are a happy place. Okay, so Stormer Joe is asking, whereabouts is Bennu in the asteroid belt? It's not in the asteroid belt. It's a near-Earth object, so it's on an orbit that brings it close to Earth. So we're looking at something that is relatively nearby. I don't have an exact map of its location relative to us right now, but I'll make sure I have that for Monday. Yeah, Larry, I don't think it's going to be NASA that funds us. We're going to have to go to the National Science Foundation, I think, and other places and things and stuff. So we're going to have to find other methods. So Paranor is asking, with the measurements of light from stars, was that a horizon distribution map shown? Oh, so the image that I showed, I should have taken a moment to explain that better. This is an image of the background light that shows in red across the middle. That is our own galaxy's equator. That's the part of the sky that it's hard to look through because we see that beautiful stream of stars across the sky. Above and below that is, well, looking out of the pole. All the little green dots on this image, those are the locations of the 739 blazars that they looked at as they were trying to map out the starlight. So it's assumed that in general, starlight is roughly the same in all directions. The question that we had, though, was in trying to measure it in other ways, that red disk of our galaxy gets in the way of most kinds of light. Now the gamma rays, those were easy, those get through. So this was the kind of research that allows us to confirm that other less accurate means were giving us good enough results that we don't need to redo a whole lot of science. This was just a new, higher accuracy, better result than any of our estimates have gotten us before, because it was a direct measurement of how starlight and gamma rays interact and thus how much starlight is out there. So looking to see what other questions are out there. Orange straw, I wear my sunglasses at night periodically too. Oh, tell us about the crazy fun times hangout coming up is what Arinster is asking. Still working on it. Ask me that on Monday. This all came up on us rather suddenly, and so it's a bit much to try and figure out all at once. Oh, 1/10 quintillionth of a Google is our Instro's way of writing out how many photons that is. It's a whole lot of light. That's what it is. Okay, do we have any other questions out there? I'd love to answer your science questions. So other things that are coming up on this channel. Sunday, Annie's going to be here bringing you office hours. I will be restarting my office hours next Tuesday night. I am here bringing you the daily space on all days that are not holidays. We will be taking off Christmas Eve and Christmas Day, as well as New Year's Eve and New Year's Day. Other than that, I should be here bringing you science. Not next week, but the week after, I'll be at a meeting of the American Geophysical Union in Washington, D.C. This may make things a little bit odd because we will be in a completely different location with all sorts of different things going on, but we will still be coming to you. So follow us on Twitter if you can and stay up to date on all the weird times that things may end up happening. Now, while we're in Washington, D.C., there will be a community meetup. We're still setting what night that's going to be. I'm currently looking at Tuesday or Thursday night as possibilities. So stay tuned to hear about that. Again, all of this stuff will go out on CosmoQuest X on Twitter, and we will be announcing things during the daily space as we learn more. So welcome, all of you. And yay science, Bill Nash. That is exactly the way to do it. Yay science. Bill Nash, can we get a shout out for Bill Nash? Bill Nash is another one of the science streamers here on Twitch. He is part of the Knowledge Fellowship. We are a group of streamers that work together to make sure there is, well, educational content you can find here among all the other richness of content that's available on Twitch. So check out all the different streamers. Bill Nash does really cool photography, including astrophotography, beautiful, beautiful images, and you just might learn something while you watch him work Lightroom. I know I did the other night. Yes, you take pictures of stuff, including sometimes nighttime stuff, which is cool. It's awesome. Hey, Lemony Zeus. That's a cool username. I don't know how some people find the strings of words they put together. Oh, you're welcome, Bill Nash. So Dat Dolphin is asking, so why are we having a look at Bennu? Because it would be close by soon, or does it have other aspects we're interested in? So one of the great things about Bennu is it appears to be an iron asteroid, and this means it's that metal kind that people keep talking about going and mining. Now, it turns out it probably isn't worthwhile to mine asteroids for metals. There's other things that some asteroids have that we may want to go get, like helium-3, which is a non-renewable resource here on the planet Earth. But also, it's close. It's easy to get to. We can do this. We wanted to bring a rock home. Sometimes you just want to pick up a rock and bring it home to study it in your laboratory where you're not confined with the same electrical and weight restraints that we have with spacecraft. So both we and the Japanese kind of got the same idea at the same time, and we built two separate missions. Our own OSIRIS-REx, they have Hayabusa 2, they're at the asteroid Ryugu, which looks remarkably similar. And both our missions to these two near-Earth asteroids are going to bring home a rock, and this is going to allow us to start to understand what exactly is the regular everyday composition of these nearby asteroids, these objects that, well, these don't have the potential to hit us, but some of their siblings have in the past. And it's curiosity, it's our ability to start to understand how it is that we came to be, because the same stuff that formed these nearby asteroids, if they formed there, and asteroids get rearranged, so these asteroids might not have formed there. But if they did, the materials locked in those rocks are the exact same materials, the exact same gases that formed our own planet. This is our only chance to go pick up a handful of what Earth was like before it got bombarded by asteroids, before it got weathered, before life originated and started mucking about with the planet's chemistry by doing things like dying and becoming oil in the case of the dinosaurs. We've changed our world. Life has changed our world. These asteroids don't have those changes. And it's a chance to go scientifically sample what got us to be what we are. I think that Bennu's actually an iron meteorite. Let me double check that. I could be confusing Ryugu and Bennu. Oh, you're right. It is carbonaceous. Ryugu is the iron. So we went to two similar looking asteroids. One is iron, the other is carbonaceous. This means it's just rock. It's the most common kind of asteroid. It's basically like grab a chunk of the Earth's mantle, throw it into space, you have a carbonaceous chondrite. That's overly simplified, but fairly close. Thank you for the catch, Larry. You're right. So Bill Wink, as far as we know, there is not a platinum asteroid. That sounds like clickbait. So many rocks, it is truly difficult to keep track of all of them, Paranor, especially where you have two so similar rocks getting explored by two very different missions that have the same ultimate goal. So Bill Nash is asking, how do we determine composition purely from observation? It comes from trusting reflected light to look similar depending on what it's reflected off of. So if you reflect light off of, and it's sunlight here, so if you reflect sunlight off of one kind of asteroid, you're going to see certain colors not reflect and certain colors do reflect. And which colors do and don't get reflected is symptomatic of what the asteroid is made of. And here on Earth, we've got a ton of space rocks. We just call them meteorites. These are samples of asteroids that tried to fall on our heads. We go out, we scoop them up, we bring them back into the lab, and we shine light on them, and we measure how light reflects off of these samples. And then we measure in the lab what is the composition of this space rock that fell to Earth. By comparing our samples that have hit the ground with what we see with our telescopes looking out, we're able to say things as particular in some cases as this rock I hold in my hand was actually once part of the asteroid Vesta, but it got knocked off in an impact at some point in the past. So we're lucky that science here is the same as science everywhere else, and rock likes to absorb light. It makes it specific colors, specific textures, and all these things factor in. It's not too different from how we tell this is a piece of granite and this is a piece of, I don't know rocks that well, olivine? I'll call it olivine. So we have granite and olivine, and you look at them and they look radically different and they reflect light differently. Well, if two asteroids are different compositions, they're going to look different and they're going to reflect light differently. Yes, Larry, spectroscopes. Hey, Mike, easy for sheezy. Um, you have a hard to say name, but your emote game is awesome. Um, so what else do we have? So our Instro Psyche was an asteroid that we went and visited. It is not made of platinum. Um, Yes, our Instro. Olivine does make green sand beaches. And olivine's actually a scientifically really important mineral because olivine only forms in liquid conditions. And this means that when we see olivine on the surface of Mars, which we do, it means that olivine formed when there was water on Mars. And we now know, because of the mineralogy, there was water on Mars. We also see hematite. It's another mineral that gets used in jewelry. It kind of, to me, looks like a drop of liquid mercury, but it's actually solid. Hematite is another mineral that forms only in liquid. Um, oh, Paranor, I didn't know that Titan could be covered in olivine. It is really cool. Um, yeah. So we don't know what we'll find, Larry, but the thing to remember about the asteroids is as many of them as there are, they don't even add up to the full mass of the moon. So it's a whole lot of scattered rock out there, and it doesn't add up to a whole lot of mass. But there are things that can exist out there in frozen forms that we lose here on Earth. Helium 3 is the one I brought up earlier. The thing about helium 3 is, well, helium in general, it's such a lightweight atom that once it gets released into the atmosphere, all it takes is a good collision with an oxygen molecule, and that transfer of momentum is going to send that helium flying off at escape velocities. So every time you have a helium balloon, you're actually being irresponsible in your use of helium, because someday we're going to run out. We mine helium. It's a byproduct of mining for natural gas and oil. We find it in the core of the planet and we suck it out. Someday we're going to run out of it. And we need helium for things like cooling down the imaging machines that we use to detect lung cancer and in other medical and engineering needs. So at some point, we're going to have to grab it from the moon. We're going to have to grab it from asteroids. And that is going to drive up the cost of your lung scan and doing scientific experiments and many other things. So don't use helium balloons. Spread the word. Anyways. So I see Spookachu is asking, what will MU69 flyby teach us with New Horizons? This is Ultima Thule. On New Year's Day, depending, wow, I moved into a realm where my green screen wants to erase part of my face. Sorry about that, folks. You're going to have to deal with part of my face erasing today. So when New Horizons flies by Ultimate Thule on New Year's Day, results may vary depending on where you are on the planet. It's going to be another chance for us to look at another Kuiper Belt object up close and get a sense of what exactly do these suckers look like. Pluto was not at all what we expected. We expected to see this highly beat up, this highly cratered surface that was completely dead, showed no signs of geologic activity, and that is not what we saw. We saw smooth glacier fields. We saw signs of convection going on. We saw not nearly as many impacts as we expected. So, yeah, we still can't fully explain Pluto, and that's awesome. And Charon was just as much of a mystery. So far, we have a sample of 2 objects that we have imaged well. 2. Ultimate Thule is going to be another. And it's small. It will be different. It can't geologically be the same. It just doesn't have enough gravity to be. But this gives us another chance to get a sense of just what is the diversity of structure out there. The more we get close-up views of asteroids, the more we realize they're all different. Well, except for Ryugu and Bennu, they look very similar. the more comets we get to see the nucleus of, the more we realize they're different. And this will give us one more chance to see just how extreme is the imagination of whatever forces that form these Kuiper belt objects in the outer solar system. It's one of those things where we don't even know what we don't know. And yes, chroma keying can be very difficult. In this particular case, the sun went behind a cloud and that did me in, but it seems to work if I turn my face this direction. So I'm going to turn my face this direction to read the comments, so I'm not chroma keying. Words, they're hard. I would love to understand what is going on with the air shark in the chat. So from Potatio, is it possible to sustainably farm helium? No. Helium, they're atoms. Atoms, they kind of do what they want. The helium that we deal with was pretty much created during the Big Bang. And the helium we've got is the only helium we're going to get. And the only way to use it responsibly is for it to never escape from our scientific systems. But the atoms are so small that they like to escape. So yeah, it's a non-renewable resource. So DPI 209 asks, can't we just fuse helium from hydrogen in a stellarator? No, we don't yet have the capacity to do that on Earth, not in a reasonable way. And helium-3 is a very specific form of helium. And no, we're not going to get there from here in a reasonable way. Yeah. Star song helium is one of those things that a lot of people don't realize just how interesting and cool it is. Helium-3 in particular means that it has 2 protons and then it has 3 neutrons, making it slightly more heavy. It's an interesting trace particle that we can use for different things. You can cool it colder than you can regular helium. It's just cool. Literally, it's just cool. What's the latest with Opportunity? Nothing, but we're still listening. Yes, helium can be created naturally with radium decay, but that's not helium-3. So we haven't given up on OPI yet. We haven't given up. It could be that it just hasn't got enough sunlight on its panels yet to fully charge. The one set of estimates I saw said that if we don't hear anything by the end of January, that's when we start worrying, because at that point, probabilities say that we should have had a significant enough gust of wind to clean anything off that was built up on the solar panels. Helium does sound like a superpower, especially when you inhale it, which you should not do. Do not do this. It does, because sound waves move through helium differently because it's a lighter gas. You end up sounding like a chipmunk. So the reason you sound like a chipmunk when you inhale helium is actually just it forces your voice box to vibrate air differently, which is awesome. Yeah, Veronica Cure, either that or we just need more nuclear powered things like Curiosity that was like, storm, I'll keep going. That's another problem though, because we don't always turn up the factories to make the polonium. We don't always turn on the factories to make the materials that we need to power the radiothermal generators. Sodium hexafluoride will kill you dead. Let's not even play with that. That's stuff that, if I remember correctly, it touches your skin and you die. I'm not a fan of being anywhere near chemicals that do that. I know they're useful for some things, but I just don't want to deal with them. Yeah, David Killiams, the tale of opportunity and spirit is one of the great achievements of science. And yeah, I love looking at how XKCD periodically writes its homages to Opie and Spirit. So Spookaku is asking, what is CosmoQuest office hours? So some of you may have gone to universities where faculty would say, okay, I'm available to answer all your questions during these specific office hours. And when you go in to find your faculty member, they're always there doing something. And this is your chance to come in while me or Annie or one of our other CosmoQuest staff members is online doing stuff. In my case, I've been working on a data visualization to destroy a planet orbiting a star. And ask me any question you want about astronomy, astrophysics, space science, and learn more about what it is that we do, and just bring any questions you want. So, other things. Yes, there is our instro, a heavier than air gas. I don't remember what it's called. I want to say its name begins with the letter B, but that is not significantly useful information. It is actually extraordinarily dangerous because the only way to get it out of your lungs, since it is heavier than air, is to cough it out forcefully. And there have been cases of people asphyxiating themselves, inhaling it just for fun to make their voice drop in pitch, and then not being able to get it out of their lungs and dying. So we have a no death policy at CosmoQuest. It's actually written into the rules. So don't do that. Don't do that. Yeah, drowning is a thing. So we have run over time, which is totally okay. And yes, cave divers and spelunkers risk that a lot. It is quite a problem. Hey, Binary Ablaze. Binary Ablaze is another one of our CosmoQuest people. Annie, she will be here on Sunday doing office hours. Can you give us a preview in a few words of what you're going to be doing this Sunday, Annie? I wanted to say Sunday, and well, I'm going to shut up. I'm losing my ability to speak. Hopefully it is sunny on Sunday. That works, Binary Ablaze. It's true. Many of the images that we initially take come in kind of boring, and before they get used in magazines and planetarium shows, in all these different places that we use astro images, we do a lot of hard work to make them look beautiful. And you can learn all about it by tuning in Sunday at 1 p.m. Eastern, noon Central, 10 a.m. Pacific. That's 6 p.m. London time. Grayscale does never look exciting. It is true. But it is time for me to take off. We will be doing a live recording of Astronomy Cast over on YouTube in just an hour and a half. So at 3 p.m. Eastern, noon Pacific, tune in on Astronomy Cast on YouTube and catch a new episode of me and Fraser recording live and hanging around afterwards to answer your questions. So thank you all. Once again, my name is Dr. Pamela Gay, and this is the Daily Space. Thank you so much for the bit. We are produced by the Planetary Science Institute, working in collaboration with Youngstown State University. We are funded by you. Every bit, every sub really matters. So thank you for helping us, well, leverage your bits to make more science for this universe. Check out CosmoQuest.org, where you can be part of helping us explore, help us map out Mars and Mercury, and figure out, well, just what's going on with all these crazy craters. Thank you, Trekker Kev. Can we light up the chat for all these fabulous bits? And thank you all for being here. And let me see if I can remember where the go button is for the credits. So thank you, and I'll see you on the other side. And wherever you are, have a fabulous morning, evening, and afternoon.